So this is a weekly pop quiz, MCQs pop quiz 8. If you have any doubt, you can ask question 1. Any doubt in question 1? Question 2, any doubt? Any doubt in question 2? Okay. Question 3, any doubt? Question 3? Okay. So in question 3, the diagram shows a force F is there and P is a horizontal component of the force. With an angle, it's making theta. So the horizontal component is given by F cosine theta because that is with an angle, and the vertical component in this case will be F sine theta. So which graph best shows a variation of with theta for the magnitude of P? Means the horizontal component is equals to F cosine theta. Now how this horizontal F is a constant, like as you can see here, this force is constant. So the variation of a P is actually depending on the cosine theta. And what is the relation between theta and cosine theta? If the value of the theta, because when the theta is 0, then cosine 0 is 1, maximum value is there. And when the theta is 90, cosine 90 is 0. So it means when the theta is 0, we'll have a maximum value for P. And when the theta is 90, we'll have a minimum value for P. So first thing, why B and C are wrong? So why B and C are showing a wrong relation? Because it shows when the theta is 0, the value of a P is also 0, but it should be maximum. And again, for C also, when the theta is 0, the P is also 0. Because the value of the cosine theta changes with an angle. When cosine 0 is there, when the angle is 0, it has a maximum value. And when the angle is 90, it has a minimum value. So when the theta is 0, we should have a maximum value. And when the theta is 90, we will have a minimum value. So B and C are totally wrong. We are left with two options. We are left with option D and A. Now, if you check the variation of the cosine with an angle, in the beginning, there's a small changes there. Example, when you take cosine 0, cosine 10, cosine 20, 30, 40, 50, or we just divide instead of taking so many intervals, we can take like cosine 0, cosine 15, cosine 30, cosine 45, cosine 60, cosine 75, and cosine 90. We know cosine 0 is 1 and cosine 90 is 0. What about the other value? Like check the variation. What is cosine 15 in degrees? Cosine 15. Cosine 15. So 0.96. What is cosine 30? 0.965. What is cosine 30? 0.866. What is cosine 45? 0.7. What is cosine 65? 0.42. What is cosine 75? 0.258 or 0.26. Look, if you check the variation of the cosine when the angle changes from 0 to 45, okay? How much that value has decreased? It was 1 and it become 0.7. So means the change in the value is only 0.3. Like it was originally 1, when the cosine 0 is there, it's originally 1, and the variation in the value, when it is 45, it is only, new value is 0.7. So the decrease in the value is only 0.3. But when you check the change in angle from 45 to 0, what you will find, it was 0.7 and it becomes 0. So how much it has decreased? It has decreased by 0.7. So what does it mean? It means when the angle changes from 0 to 45, the value change will be smaller. But when the angle changes from 45 to 90, the value change will be greater. So that's why A is the right answer. Is it clear? So remember, for a cosine, when the value of an angle, when a value for an angle, it changes from 0 to 45, the change in the value of the cosine, like this is 1 and this is 0.7. So the change in angle is only 0.3, the difference in the value of the cosine. But when it changes from 45 to 90, the change in the value is 0.7, because this is 0.7 and this one is cosine 90 is 0. So the change in value is 0.7, which is a larger decrease. So till 45, 0 to 45, smaller change, and but from 45 to 90, it should be a larger change. That's why even though A and D both shows the change, but in D it is opposite. Like if this 45 will be here, so you can see from 0 to 45, it shows a greater change. And from 45 to 90, it shows a smaller change in the value. But it should be opposite, that from 0 to 45, when 45 will be here, so 0 to 45, it will have a smaller change. But from 45 to 90, it will have a larger change. Is it clear? Any doubt in this? Okay. Question 4, 5, any doubt? This was a weekly pop quiz. Question 4. In question 4, a student wishes to measure a distance about 10 centimeter to a precision of 0.01. So a distance of a 10 centimeter. Look, the thing is that when we use a micrometer, we cannot, 10 centimeter means, like when we convert into millimeter, the smallest value, which instrument, measuring instrument should be used? For a meter rule, the smallest value it can measure is 0.1 centimeter. A micrometer is 0.01 millimeter, or 0.01 millimeter is there in terms of millimeter. For a measuring tape, it is 0.1 centimeter. And for a vernier caliper, it is 0.01 centimeter. So which is the most accurate? We want to precisely measure 0.01 centimeter. So which is the most accurate instrument here to precisely measure 0.01? So it matches with a vernier caliper. For a micrometer, it will be 0.001 centimeter. So the precision of a micrometer is more than what we want to measure precisely. That's why we are not using a micrometer. And another thing, if you see the length of a 10 centimeter for measurement, like micrometers cannot be used for this 10 centimeter, minimum 5 centimeter length can be measured by using a micrometer. So the higher limit is greater. That's why a micrometer is not preferred. And the precision of the value which we want matches with the vernier caliper. That's why D is the right answer. Is it clear? Question 5, any doubt? In question 5, what is the percentage uncertainty in the value of a G? So how you will find the G? If we need G, it will be 2h divided by t square is equals to G. So the percentage uncertainty in G will be the percentage uncertainty in height and the percentage uncertainty in t square. How to get the percentage uncertainty in height? that is 0.01 divided by 4.05 into 100. That will give us the percentage uncertainty in height. To get the percentage uncertainty in t, so percentage uncertainty in t is the smallest value, the least count, divided by value recorded into 100. But because it's t square, so what we have to do, if we want t square, we'll multiply this by 2. So the percentage uncertainty in t square plus the percentage uncertainty in height. So like this will be 4.3%. And the percentage uncertainty in height, that is 0.24%. So 4.3 plus 2.24, that will give 4.56%, and 4.56% is approximately 4.6. So B should be the right answer for this. So if it's a cube, then we'll multiply the percentage uncertainty by 3. So individually, we'll work out the percentage uncertainty. If it's a square, we'll multiply by 2, cube will multiply by 3 and add the individual percentage uncertainties. Question 6 or 7, any doubt? Question 7? Okay. Question 6? Okay. In question 6, a stone is thrown vertically upward from a point x. So this is point x where t is equals to 0. The variation with the time of the velocity is shown. So as you can see, a stone is thrown vertically upward. So it means the positive axis is used for that velocity. So all the upward motion, all the upward velocity directions are considered as positive, and all the downward directions are considered as negative. Now, if we need the displacement, so if we want a displacement, we can use the area under the graph. So first, when time is equal, like when we launch this, throw this vertically upward, the time is equals to 0. When time is 2 seconds, it reaches the maximum height. And then it is coming down. As you can see, the velocity is negative. It means this final velocity is minus v and the initial velocity was u. So whenever a speed time graph or a velocity time graph is there and you need a displacement, so you can take area under the graph. And if you are using a positive axis or a negative axis, you will simply add. If one part of a graph is in positive axis and another one is a negative, you will subtract. So here, first what we do, we'll find the area of this part when it is going up. So it will be half, the base is 2 and the height is 20. So when we simplify, we got 20 meter. Then we find the area when it is coming down. This is the area. So it will be half, the base is 1 because it started from 2 and ending at 3, and the height is minus 10. So when we simplify, it will be minus 5 meter. So what is the displacement? Going up 20 meters. Going up 20 meters. So that was plus 20. And then it is coming down minus 5 meter. Like negative displacement is minus 5 or opposite displacement. Or opposite distance it covered. So what is the displacement? Displacement is always from the starting position to the final position. So this is a displacement. So it is plus 20 and minus 5. So plus 20 minus 5 is equals to plus 15 meter. So 15 meters. Now, is it above or below? So how to identify this? Is it above or below? When we simplify, our answer is positive. If our answer is positive, means it is the above this, the launching position. If it was answer was negative, like when we simplify and our answer was coming out negative, it means it's a below the point x. So this object is above point x. So this is the 15 meter and that is above point x. That's why A should be the right answer. Is it clear? Question 6. In question 7, an object is there on the inclined surface. The mass is 5 kg is released. on from a rest. So if something is released from the rest, the initial velocity is 0. What is the acceleration on the inclined surface when object is there is no friction? So A is equals to g sine theta. I can derive this formula as well, but I want you to memorize that whenever there is no friction, the acceleration on the inclined surface is g sine theta. How this is derived? You don't have to derive this formula in the exam. Try to memorize, but right now I will derive this. That this is theta. So the one which is with an angle, that will be W cosine theta, and the opposite to the angle will be W sine theta. So W sine theta is causing an acceleration. So according to Newton's second law, F equals ma, where F is a resultant force, which is W sine theta, is equals to ma. W is mg, so mg sine theta is equals to ma. M will cancel with m, so g sine theta is equals to a, or expression is g sine. So remember on inclined surface, whenever it's a frictionless surface, acceleration on the inclined surface is always g sine theta. That's fixed. So you can derive this, but no need to derive in exam the formula. Just remember that acceleration on inclined surface, frictionless surface, is always g sine theta. How far does the mass travel at a time? So we have the time, we need the distance. So initially it was rest. Acceleration is g sine theta, means g sine 30. And the time is 0.8. So we need the displacement. If we need the displacement, we can use equation of the motion, the relevant equation, which is having u, a, and t, and s. So if I use s is equals to ut plus half at square. So just substitute the values. Initial velocity is 0. The time is 0.8 plus half. Expression is due to g sine theta. So g sine 30 or 9.8 sine 30 times 0.8 square. So 0.8 square multiplied by sine 30 into 9.8 divided by 2. This factor will be 0. So that will give us the displacement of this object on the inclined surface. Is it clear, this one? So A will be the right answer, yes. So on an inclined surface, the frictionless surface, acceleration is g sine theta. Question 8 or 9, any doubt? Question 8. What is not a statement for one of the Newton's law of motion? There are 3 laws of the motion for Newton's first law, which state when object is, there is no resultant force, the object will not accelerate. If there is a resultant force, the object will accelerate, and action and reaction forces are equal but opposite in direction. So if we check, if body X exert a force on a body Y, the body Y will exert an equal opposite force. That is true. And which law it refers to? It refers to Newton's third law. No resultant force act on a body. It has a constant velocity. That's true also. And it refers to Newton's first law. The rate of change of momentum of a body is proportional to resultant force. And acting on it take place in a direction of the force. This is actually Newton's second law. How momentum and the Newton's second law are related? Look, we say F is equals to ma. We got F is equals to ma. That according to Newton's second law, that the resultant force act on the object is a product of mass and acceleration. So what about the acceleration? Acceleration is v minus u over t. If I simplify this, the formula will be F equals mv minus mu divided by t. What is mv minus mu? That is a change in momentum. And it is written the rate of change in momentum. Means this is the rate of change in momentum. It is directly proportional to, this is a rate of change in momentum, and it is directly proportional to resultant force. So actually, this statement has converted F equals ma, has converted into option C, that the rate of change in momentum, so it is refers to second law. The total momentum of a system of interacting body is constant if there is no external force. This is correct, but this is not the Newton law. This is a law of conservation of momentum. So D is actually not the statement of the Newton's law. It is a conservation of momentum. Is it clear? Why D? Because D is not the Newton law. Like Newton does not explain that momentum is conserved when there is no external force act on it. It is not given by the Newton of in the motion. It is actually a true statement, but that is a conservation of momentum, not the Newton's law. So this statement is not the Newton's law. This statement is a conservation of the momentum. It is true, but not the Newton's law. Rest A, B, C are actually statements which are derived from the Newton law or from the Newton's law. Question 9, any doubt? Question 10. For an elastic collision, what is the condition for an elastic collision? The momentum must be conserved. Means momentum before and after collision should be same, and the for elastic, and the kinetic energy should be same. But they say which collision is not elastic. So inelastic collision, kinetic energy is not conserved. Not conserved means like it is not same before and after. Momentum should be same, but the kinetic energy should not be same. So what you have to do, you have to check the conservation of momentum first. If conservation of momentum is fulfilled, then move on to conservation of kinetic energy. Kinetic energy before and after should not be same for a not elastic collision or inelastic collision. So what is the momentum here? Before 2 so this is equals to 2m times 4. So it is 8m and this is m. So what is the total? Because they're in the same direction. So before is 9m. What about this? This is 4m and this is 5m. So the total momentum before and after, it is 9m. So momentum is conserved. Now check kinetic energy. To check the kinetic energy, yeah, it is fine. That's true. Directly. But the thing is, why I was calculating, knowing the momentum, because if the momentum is not conserved, I will not move on to check the kinetic energy directly. Because both statements should be correct, that the momentum should be conserved as well as the kinetic energy. So like this one, 6 multiplied by 2, 12. And like 12m is there and this is 3m. So total is 15m. This is 8m and this is 7m. So momentum is conserved here. For this one, 16m. Yes, there's also another way. You can also check the relative speed of approach and separation. Using that, you can in a short time it can be done. This is 2m, so total is 18m. This is also 18m. This is 20, 24, and this is also 24. So all of them momentum is conserved. Just you have to check the kinetic energy. It will just you have to check kinetic energy, which is half mv square. Like this will be 2m 4 square plus half m 1 square. So when you simplify this, this will be 16m and this will be m by 2. So when you simplify, 2 will be an LCM, so it will be 32m plus m. So this is 33m by 2. That is the kinetic energy. Same way you have to check the kinetic energy for all of this. It will be half, it will be 2m into 2 square plus half m into 5 square. So when you simplify this, 2 square is 4 multiplied by 2, 8m divided by 2, and this is 25m divided by 2. So when you simplify, When you simplify this, so it will be 33 m by 2. So the kinetic energy before and after is same. So it means this is an elastic collision, but we are looking for an inelastic collision. So A cannot be an answer. Same way you have to check for all the other options. Is it clear? Any doubts in this? So correct option when we check, like example, we check for C. So it will be half mv square. If it is half mv square, so half 2m into 8 square plus half m into 2 square. So you simplify, don't cancel out 2 at the last, you can take an LCM. So 8 square, 64 times 2, so 128. 128 m by 2, and this is 4 m by 2. So it will be 132 m by 2. So now you simplify this, so it will be 66. So 66 m. What about this one? So it will be half 2m 5 square plus half m 8 square. So this will be 2m times 25. So this will be 50m. So 50m by 2. And this is equals to 64m by 2. So when you add them, so it will be 114m by 2. When you simplify this, so this will be about 57. So 57m. So this is 57m, this is 66m. So option C is the right answer, that the kinetic energy before and after is not equal. Is it clear? The calculation? Question 11, any doubt? Question 11. Question 11, the diagram shows a ballistic pendulum. A pallet of a mass m is traveling at a speed u, hits a stationary block of a mass m. The pallet becomes embedded in the block and causes the block to move with the speed v. Because if it is embedded, it means they will move with the same speed, which is v. When a pallet of a mass 2m, like they repeated, the pallet is there of a mass 2m, traveling is a speed 2v, it hits a block of a mass 2m, what is the speed immediately after the impact? So first we take the first scenario, because two different scenarios are there. We take the first scenario and we apply the conservation of the momentum, that the momentum before should be equals to momentum after. Whenever collision are there, this give an idea that I should use a conservation of momentum. So total momentum before, this pallet of a mass m was using with the velocity u, and the block was stationary, so it has a zero momentum. Then there, like the pallet embedded, and it means it moved together with the same speed. So it will be mass of the pallet and its velocity will be v, and the mass of a block and its velocity will also be v. Because they stick together, when two objects stick together, they will have the same velocity. So this will be mu, and this, if I take v common, so it will be small m plus capital M, or if we further simplify this, so it will be mu over m plus small m plus capital M. That is the first scenario, like when the pallet was having a mass m and the block was also having a mass capital M, and it was moving with velocity u. Now the second scenario, that, and we need what velocity it is moving. Now the mass of a pallet is 2m and its velocity is 2u. The mass of a block is 2m. This is what we need. Say this is now x. So again, we'll use a conservation of the momentum. So mass of a pallet is 2m and its velocity is 2u. Plus the mass of a block, the momentum of a block is 0 initially. This is a second scenario when the mass is doubled for every object here. And the speed is all velocity or speed is also double. Then they stick together, again they stick together and move. So we can also say like the mass will be 2m, this new speed is x, plus the mass is equals to 2m and the speed is also x because they stick together. Now we simplify, this will be 4mu. If we take x common, so it will be 2m plus 2 capital M into x. This will go there in division. So 4mu divided by 2m plus 2 capital M. That is x. If I simplify this equation, if I simplify this equation, this relation, so this is 4mu divided by, if I take 2 common, so it will be small m plus capital M is equals to x. So this 2 can cancel with this 4, so this will become 2. So this will be 2mu divided by m plus capital M is equals to x. Now what is this value? What is this mu divided by m plus small m plus capital M? This is mu divided by small m plus capital M, that is v. So I can say that 2v, because this whole is equals to v, so 2v is equals to x, or x is equals to 2v. So that's why C should be the right answer for this. Is it clear? Question 11. Question 12, any doubt? Look, in the question, they ask which arrangement of a force produce a total moment. They ask so, and we have x as a center of a disk is there and it is rotating. So the distance from the pivot, which arrangement of forces provide a total moment or total turning effect with a magnitude of 2Fr. About x means x is a pivot, okay? And the radius of the disk is r, as they mentioned in the question. The radius is r. So what is the turning effect of this one? It is F into r. And what is the turning effect of this one? The other upward force, that is also F into r. Because two are in the same direction, so if I need a resultant, how to get the resultant? So resultant will be Fr plus Fr. Because what I will do, as the two moments or turning effects are in the same direction, we'll add. So what is the total moment in this case? So it will be 2Fr. That's why A will be the right answer. What about B? This radius is r, the perpendicular distance. So what is the turning effect here? It is F into r, the moment. What about the turning effect in this one? So this is causing F into r clockwise. This is also causing F into r clockwise. And this is causing F into r anti-clockwise. So these two cancel out each other. So it means moment will be there equals to F into r, the turning effect. What about the option C? The distances are here and distances are. So this causes a turning effect F into r clockwise and the other one causes F into r anti-clockwise. So the net turning effect will be 0 in C. So whenever we need a turning effect or a moment, resultant moment, we add. If they're in the same direction, we add. If it's in opposite direction, we subtract. If the question was, what is a moment? The same question was there. What is a moment due to a couple? Okay. So what is a moment due to a couple when two forces are acting in opposite direction and they give rise to a turning effect in the same direction? We call moment due to a couple. So here we can directly work out moment due to a couple. So moment due to a couple is a force multiplied by distance between the two forces. So what is the distance between the two forces? That is 2r. So I will also get the same result, F into 2FR. That is what we get. So moment due to a couple is a force multiplied by distance between the two forces. Question 13, any doubt? 13, 14. Question 13, 14, 15. Any doubt? Question 15, okay. A cylindrical block of ice has a cross-sectional area of a 12 meters square. It is floating. So if it is floating, it means the total downward force is equal to total upward force. Okay? Because it is floating. And it is partially submerged. Question 14. Okay, I will solve question 14 as well. The density of the seawater is 1020. A polar bear of a mass is 400 kilogram. The block of an ice sink a vertical distance d. So what we can say, first thing, because it is floating, so we can say weight will be equals to upthrust. Okay. So I can say weight will be equals to upthrust. What about upthrust? Upthrust is density of the fluid, volume of object submerged, like how much object is inside into gravity. And what about weight? Weight is mass times the gravity. So G will cancel with G. So I can say M is equals to density into volume of object. But this is not the volume of object completely. This is the volume of object submerged. And the volume of this object submerged, like example, if it submerged a distance D, like the thickness D. So this thickness is D and the area is A. So what is the volume? So it will be equals to density times area into D. D is the distance it sink. Like how much block of ice sink vertical distance D, that is D. And area of the ice is A. And so the total volume of the ice which is submerged in the total volume of the ice which is submerged in the water, that is A into D. Because volume is area multiplied by height for a cylinder. So we have the mass which is 400. We have a density which is 1020. And we have the area which is 12. So we need D. How much, what thickness is there or what vertical distance is underwater. So we just simplify. So it will be 400 divided by 1020 times 12. So what's the answer? 400 divided by 1020 times 12. How many in terms of meter? So 0.3 meter. Okay, this is a volume 0. No, this is not 0.03. So 400 divided by 1020. So we have 0.03 meters. But if we convert into centimeter, we divide